Hi everyone. Today I am going to discuss derivative definition by problematic approach, that is computation approach. Previously I discussed geometrical approach. Now how to find the derivative through limits method, that is problematic approach. And then partial derivatives with example, and then mean value theorems followed by maxima minima. So in the last class we had discussed limits procedure using standard limits, indeterminate forms, in some situations left hand limit, right hand limit, then continuity, discontinuity, etc. Now continuation. Definition. A function f of x is said to be differentiable at x is equal to a if f dash a is equal to limit x tends to a f of x minus f of a by x minus a, or limit h tends to 0 f of a plus h minus f of a by h. Provided that the limit exists. This is just by slope of a straight line or chord joining 2 points. In the limiting case, that chord becomes tangent. Every tangent has a slope. That slope is called here derivative f dash a. That is f of x derivative at a point x is equal to a. And this method limit h tends to, that is first order principles. That is from 11th class. Prove that the derivative of sin x is equal to cos x by this method only. Okay. So, and this f dash a is also denoted by dy by dx at x is equal to a. Now, when any definition related to limiting method, that is the limits method, automatically there you are having left as well as right. That means left hand derivative, right hand derivative. The left hand derivative short form LHD, abbreviated as LHD, of f of x at x is equal to a is given by LF dash a is equal to limit x tends to a x less than a f of x minus f of a by x minus a. I told you in the last class left hand continuous, I mean left hand limit, right hand limit. Similarly here left hand derivative, right hand derivative. When there is a continuity, similarly left hand, left continuous, right continuous also. And right hand derivative in bracket RHD of f of x at x is equal to a is given by r f dash a is equal to limit x tends to a, x greater than a, fx minus f of a by x minus a. When left hand derivative not equal to right hand derivative, then f of x is not differentiable at x is equal to a. When left hand limit not equal to right hand limit, we already have learnt limit does not exist. When left hand derivative not equal to right hand derivative, then the derivative of f of x at x is equal to does not exist. That is f dash a does not exist. Left hand derivative is equal to right hand derivative when these two are equal, which is equal to original derivative, that is f of x derivative at x is equal to a. X is a variable, it has many values. One of the value is a. A is a constant. Now let us see the example. So in the last week I told you geometrically, that is the graph of mod x. Okay, it is a V shape which is symmetrical about y axis. Okay, that time I told you is differentiable at everywhere, that means at every x except at origin, that means at x equal to 0. So that geometrical interpretation now I am going to prove, that is mod x is not differentiable at x equal to 0 by this method. Okay. Example. Find the derivative of f of x is equal to mod x at x equal to 0. So the function is mod x and a value is 0, that is origin. Solution. So in the last class we know that mod x is equal to plus x if x greater than 0, minus x if x less than 0. So that means when x less than a, that is the information by left limit. When x greater than a, that automatically tells the information right hand limit. Similarly here also, when x less than 0, when x greater than 0, it has different values. It means mod x has different values, one is plus x and minus x. So due to that, we have to find the derivative by left hand derivative and right hand derivative method, not by directly. And moreover, I gave mod x derivative formula at every x except at x 0. That means d by dx of mod x is equal to mod x by x if x not equal to 0. Okay? That means automatically when x equal to 0, the derivative does not exist. That I am proving by this left hand derivative, right hand derivative method. So LHD at x is equal to 0. So what is the LHD means? Left hand derivative. Okay. So limit x tends to 0, x less than 0, that is a value 0, f of x minus f of 0 by x minus 0. When x less than 0, that means first of all limit x tends to 0, x less than 0, fx means mod x, f of 0 means mod 0, 0 divided by x minus 0 means x. So when x less than 0, what is mod x? Minus x. That means limit x tends to 0 minus x divided by x. So x cancelled. Okay. So it remains with minus 1, which is a constant. Limit of a constant is itself. So, minus 1. So, the left hand derivative value is minus 1. Now the right hand derivative. RHD at x is equal to 0. So RHD notation, that is limit RF dash A, limit x tends to 0, x greater than 0, f of x minus f of 0 divided by x minus 0. So this is equal to limit x tends to 0, fx is mod x minus f of 0 mod 0, x minus 0 value x. So x greater than 0. When x greater than 0, what is mod x? That is plus x. Limit x tends to 0, x divided by x. X cancelled. It remains with 1. 1 is a constant. Limit of a constant is itself. So the answer is 1. So right hand derivative 1, left hand derivative minus 1. Both are exist, but they are unequal. So therefore LHD not equal to RHD. Therefore f of x is not differentiable at x is equal to 0. So here the question is find the derivative of f of x is equal to mod x at x equal to 0 if exist. You can add the word in the question if exist. Copy it. Next. Partial derivatives. So, in ordinary derivatives, that is dy by dx, okay, which is having one dependent variable and other is independent variable. So, that means we are differentiating dependent variable with respect to an independent variable. So, if a function containing more than one independent variable, that means function is considered as dependent variable, other variables considered as independent variable. So, if it is more than one independent variable, then it takes place, that is partial derivatives. That means partial derivative means same as ordinary derivative procedure or formula, but keeping all other independent variables as constants. Okay, see, let u is equal to f of x comma y. That is, u is a function of two independent variables x and y, where u is dependent variable and x comma y are independent variables. Then, number 1, dou u by dou x or ux. Some people denote by suffix notation or some other people denote by this one. How you read? Del u by del x. Some people in some regions, so they are reading del u by del x. Some other people dou u by dou x. Okay, is called the partial derivative of u with respect to x. Keeping y constant. Okay, that means in other way, that is the derivative of u with respect to x keeping or treating y as constant. Okay, so the derivative of u with respect to x keep all other independent variables as constant is called partial derivative of u with respect to x. What is here all other independent variables? If you are differentiating with respect to x, other independent variable is y. Okay, number 2, dou u by dou y or u suffix y is called partial derivative of u with respect to y. So here we are differentiating u with respect to y, keeping x as constant. So such derivative is called partial derivative of u with respect to y. Here x constant in this case. Okay. So similarly, second order partial derivative. Dou square u by dou x square or denoted by u double x suffix double x. This is nothing but dou u by dou x, dou u by dou x. Next, dou square u by dou x dou y or u x y is equal to dou by dou x of dou u by dou y. And finally, dou square u by dou y square is equal to dou by dou y of dou u by dou y. In all ordinary cases, that means when the function u, that is a dependent variable u, has continuous second order partial derivatives, then dou square u by dou x dou y is equal to dou square u by dou y dou x. That means u x y is equal to u y x in general. Okay. So here dou square u by dou y dou x or u y x is equal to dou by dou y of dou u by dou x, etc. That is so on. Example 2014, 2 marks. If z is equal to xy into log of xy, then option A, x dou z by dou x plus y dou z by dou y is equal to 0. B, x dou z by dou x is equal to y dou z by dou y. C, y dou z by dou x plus x dou z by dou y is equal to 0. D, y dou z by dou x is equal to x dou z by dou y. Solution. So, here z is a function of two variables x and y. That means you have to consider z as dependent variable because we are finding the derivatives for z only with respect to x and y partially according to the options, that is the terminology provided in options. Okay. So, z is a dependent variable, x comma y are independent variables. So, using properties of logarithms, that is log mn is equal to log m plus log n. So, that I can write now xy into log x plus log y. So, can I write like this? Okay. Now, implies dou z by dou x. What is that? Partial derivative of z with respect to x. Automatically in this case, y constant. Now, so y into remaining terms, x terms, dou by dou x of x into log x plus log y. So, can I write like this? Okay. So, you following or not? So, this is product of two x terms. One is x, other is log x plus log y, denoting by uv. That is, it is a uv rule, product rule differentiation. So, v into u dash plus u into v dash. That means y into, with respect to x and keeping y as constant. Please remember, concentrate. So, v means log x plus log y into x derivative with respect to x is 1 plus x into v dash. That is log x derivative with respect to x is 1 because y constant, log y also constant. Constant alone derivative is 0. That means log x derivative is 1 by x. So, now this x into 1 by x 1. So, again log x plus log y, I can write log of xy. So, finally I can write this is y into 1 plus log of xy. So, similarly, comma, dou z by dou y. So, in this case, partial derivative of z with respect to y means x constant, x terms constant. So, just like as above, you will get the answer x into 1 plus log of xy. Now, some solutions, explanation compulsory depends on option y. In some solutions, some problem, not every problem. See, which option satisfied for my dou z by dou x, dou z by dou y? For example, if I multiply by x here and for this multiply by y, adding, you are not getting 0. So, subtracting, you will be getting 0. That means x dou z by dou x is equal to y dou z by dou y. Therefore, x dou z by dou x is equal to y dou z by dou y. So, for dou z by dou x, both sides multiply by x. For dou z by dou y, both sides multiply by y. You will get same. Next, this is one. Number 2, this question asked in 2008, 2 marks. Let f is equal to y raised to x. Then dou square f by dou x dou y at x is equal to 2, comma y is equal to 1 is dash. So here f is dependent variable and xy are independent variable. So as far as any derivative consider, numerator variable is generally taken as dependent variable. The denominator variables considered as independent variables. So that means here f is a function of x and y. That's why f is dependent variable, x comma y are independent variables. So I told you how to evaluate second derivative. First, partial derivative with respect to y. For that term, find partial derivative with respect to x. That is the second derivative. Solution. Dou f by dou y. That means dou by dou y of y raised to x. So in this case, x constant. So here the x is at power position. When the power is constant, base is variable, just compare with x raised to n, x to the power n. That is n into x to the power n minus 1. So this is x into y to the power x minus 1. Okay. X into y power x minus 1. So now I can write this is x by y into y power x. So finally dou square f by dou x dou y is nothing but dou by dou x of dou f by dou y. So here you are doing partial derivative with respect to x. That means y terms constant. So when a constant is multiplying, which will come out as it easily. That means it is better to put out. So 1 by y, it is a constant we are doing with respect to x into dou by dou x of x into y power x. So we are differentiating that inside term with respect to x, which is a product of two x terms. I can denote by again UV rule, product rule. This is u and this is taken v. So 1 by y into v into u dash, y power x into x derivative with respect to x is 1 plus x into y power x derivative with respect to x, y is constant. Here y means base. When the base is constant, you compare the term is a power x. A power x derivative is a power x into log a. So y power x derivative with respect to x is y power x into log y. Then after that they are asking at x is equal to 2, y is equal to 1. That means substitute x value 2 and y value 1. Okay. When y1 power any number is 1, log y value, that means log 1 value 0. So 1 by 1 into 1 plus 0, finally it is 1. D by dx of derivative with respect to x power a. Power a is constant, a into x power a minus 1. The same derivative, that means d by dx of a power x, when the base is constant here, a power x into log a. So both a is constant. In both cases, a is constant. In one situation, a is power. In other situation, a is base. The next definition is total derivative. Let u be a function of two independent variables, that is f of x comma y, and x is a function of t variable alone. Similarly, y is another function of t variable alone, where t is a parameter you can take as, that is, u is a function of x comma y and x comma y are functions of t. Then, number 1, u is a function of t alone. Number 2, du by dt is equal to dou u by dou t dou u by dou x into dx by dt plus dou u by dou y into dy by dt. I will explain. Actually, this is not considered as a formula. U is a function of t alone, then followed by n, first result better, like this. Number 2, du by dx is equal to dou u by dou x into dx plus dou u by dou y, dou u by dou x plus dou u by dou y into dy by dx. Number 3, du is equal to dou u by dou x into dx plus dou u by dou y into dy. These are 3 types of total derivative. So this is called, third one, total derivative of u, and this is called total derivative of u with respect to x. This is total derivative with respect to t. So the second result is obtained by putting t is equal to x, and the third result is obtained from second result by shifting the denominator dx into the right side. So easy to remember. So when u is a function of two independent variables x and y, naturally two partial derivative takes place, dou u by dou x, dou u by dou y. And x comma y are functions of single variable t alone. So when it is a single variable, then ordinary derivative takes place. That means dx by dt, dy by dt. This is also called chain rule. Also called the first one, chain rule. Chain rule, differentiation. Just like 11th class, one variable. Y is a function of z, and some z is equal to some function of x. How do you find dy by dx? dy by dz into dz by dx. So here y is a function of one variable, z is a function of one variable. But here u is a function of two variables, and these two variables are functions of single variable, that is t. That is why partial derivatives as well as ordinary derivatives takes place. But this rule is chain rule from ordinary derivatives, 11th class. This is chain rule from partial derivatives. Okay. So In the second formula, this is to be taken care. How do you find dy by dx? Okay, so that I am writing here. If f of x comma y is equal to c, c means constant, is implicit or explicit function, then dy by dx is equal to dou f by dou x divided by dou f by dou y. So, when a function containing both variables, from that if we express y in terms of x, such a function is called explicit function. If you do not express y value in terms of x, such a function of x comma y is called implicit function. For example, see, x cube plus y cube plus xy is equal to 1. Can you solve y value in terms of x? It's not possible here. So this example is called implicit function. X square minus y is equal to 0. Can you find y value in terms of x? Yes. From this, y is equal to x square. So such a function of x comma y is called explicit function. This is implicit function. In both cases, you can find dy by dx, just like from 11th class also. Without partial derivatives, you can get dy by dx. But using partial derivatives, that dy by dx formula is very easy by this method. So please take care. I am going to do one gate problem and one other example. In this case, number 1, this question asked in 2009, 1 mark. The total derivative of xy is. So, for which function we are finding total derivative? The function is product term x into y. So, let us denote that x into y by u function or f function, anything. Solution, let u is equal to x into y. Okay? Then the total derivative of xy is nothing but du. That du is the above third result. Dou u by dou x into dx plus dou u by dou y into dy is equal to, what is partial derivative of u with respect to x? That means y constant, y into x variable, x terms with respect to x derivative with respect to x, 1. So, y into remaining dx plus, what is dou u by dou y? Partial derivative of u with respect to y means x constant. X into y derivative with respect to y is 1. So, finally it simplifies x. So, that means your answer is y dx plus x dy. You can get this by 11th class ordinary derivative method also, but partial derivative takes less time. Next, number 2. The total derivative of x square y with respect to x, where x and y are connected by the relation x square plus xy plus y square is equal to 1, comma is. Solution. So for whom? For which function we are finding derivative x square y with respect to x? So take x square y u variable. That means the requirement is du by dx, total derivative of u with respect to x. So let u is equal to x square into y implies the total derivative of x square into y with respect to x is nothing but du by dx. So what is du by dx? Dou u by dou x plus dou u by dou y into dy by dx. Let us say equation 1. So for the given u, we can find dou u by dou x, dou u by dou y easily. But in this case, we should need separately dy by dx. How do you get that dy by dx? They should provide a separate relation between x and y. There is x and y connected by the relation. So this function is taken as implicit or explicit function. Okay. Now, let f of x comma y is equal to x square plus xy plus y square. Okay. Is equal to 1. So this 1 is denoted by c. Implies dy by dx is equal to dou f by dou x divided by dou f by dou y is equal to partial derivative with respect to x is x square derivative 2x. So kindly excuse me, all of you come back to this. The derivative is dy by dx formula is minus dou f by dou x by dou f by dou y. Please modify everyone. So this is minus dou f by dou x divided by dou f by dou y. So minus of partial derivative with respect to x of x square is 2x and here y constant, x derivative 1. So 1 into y means y. Y square alone constant, constant derivative is 0, bracket close, divided by partial derivative with respect to y means x square constant 0. Sorry, y derivative with respect to y is 1 because x is constant, x into 1 is x, y square derivative with respect to y is 2y. So therefore 1 implies, that means 1 simplifies to du by dx is equal to, what is dou u by dou x? Here you took u is equal to x square y. For this partial derivative with respect to x means x square derivative 2x, y is multiplication constant. So 2xy plus partial derivative with respect to y means x square constant, y derivative is 1. So x square into 1, x square into dy by dx just now we got minus 2x minus 2y by x plus 2y. Depending on the options, you simplify further, that is by taking LCM or not. Next, mean value theorems. There are two mean value theorems mainly. One is Rolle's theorem, other is Lagrange's mean value theorem. Number one, Rolle's theorem. Let f of x be a function defined in closed interval a comma b such that number one, f of x is continuous in closed interval a comma b. 2. f of x is differentiable in open interval a comma b. 3. f of a is equal to f of b. Then there exists C belongs to open interval a comma b such that f dash c is equal to 0. Next, Lagrange's mean value theorem. Let f of x be a function defined in closed interval a comma b such that number one, f of x is continuous in closed interval a comma b. 2. f of x is differentiable in open interval a comma b. Then there exists C belongs to a comma b such that f dash c is equal to fb minus fb fa divided by b minus a. Small s dot t means that is the abbreviated as such that, or you can write like this, such that. So Lagrange's mean value theorem. The next one is Taylor series or the applications of Rolle's theorem. And for all these, we can prove some tough inequality problems, and a function is increasing, decreasing. That is one of the application by Lagrange's mean value theorem. And some errors applications from 11th class, we can do some problems by Lagrange's mean value theorem. Next, some of the infinite series. Every infinite series is not convergent. That means may or may not be convergent. So some we know in our childhood class arithmetic geometric progression, that is 10th class, 11th class, or geometric progression only. But there are some other series invented by Taylors. That means many engineering science problems, we have some unlimited terms. In that case, we cannot simplify sum of infinite terms. So we have to consider approximations only, some limited terms. Due to that, we will get naturally an approximation. So that approximations are available by Taylor series. All these mean value theorems applications only. All of you please take a break. If you have any doubts, please ask the current topic doubts.